Alright guys, sorry about this part 3. My microphone stopped working halfway through the video, so we're just going to continue on. And what we're going to do is we're going to graph our first set of points here. So this y equals -3 and -2x. Remember, this is going to be our number 1 equation, so we're going to start it at -3. And since my slope is a -2, what I'm going to do is go down 2 and to the right 1, down 2 to the right 1, down 2 to the right 1. Alright, so now since we've gotten to the edge of our graph on the left side, what we're going to do is go up 2 and over 1, and then up 2 over 1 again. Oops, I went a little too far for those two. Okay, so keep graphing. Remember, all the way to the edge of the graph so we can clearly see what's going on. And we're going to take our ruler and do it like this. Making a nice line. Make sure you draw your arrows at the end. Alright, so now we have -2 for my red. And it's also going to be down 2 over 1, down 2 over 1. Now, if you see these, they are not quite intersecting, like at all. They're right next to each other. They do not clearly hit the same numbers. Sometimes we'll have equations like this that look super close to it. That's what happens sometimes. Let me draw it real quick. But as you can see, they're never going to intersect each other. So let's look at the middle one here. I have -1 as my y-intercept. And my slope for this one is up 5 and to the right 2. So I'm going to go 1, 2, 3, 4, 5, and over 1 and 2. Okay, so you're going to keep doing this. 1, 2, 3, 4, 5, 5, and over 2, and put a dot. Okay, then I'm going to go the opposite way, down 5, 1, 2, 3, 4, 5, and over 2. 1, 2, 3, 4, and that's as good as it's going to get because I can't draw it any further. So I'm going to go like this, line it up, draw your line, and then I'm going to do the red one again. And this time we're starting at +1, and I'm going to go down 1 and over 5. 1, 2, 3, 4, 5. 1 all the way to 5. Okay. Then if I did the opposite way, I'd go up 1 and over 1, 2, 3, 4, 5. Up 1, 1, 2, 3, 4, 5. Oops. Alright. So, now we're going to draw our line. And you can see that this one intersects right at some point. And now my last one. So what we have here, you can see that my slope is -3, meaning I'm going to go down 3 into the right 1. Same thing, whoops, same thing with my red line. My slope is -3 over 1, meaning I'm going to go up 1 and to the right, or sorry, down 3 and to the right 1. So let's see. I'm going to start at 4 for this blue, the purple one. I'm going to go down 1, 2, 3, and 1, 1, 2, 3. And keep doing this until you get all the way again to the edge of your graph. Yes, I'm going to keep saying that every time we graph till you know what to do in order to not graph wrongly. Alright, 1, 2, 3. Alright, so I got my purple graph here. And I'm going to draw a line. And guess what? The red is going to be exactly the same. It's going to start at 4 and go down 3 and over 1 and up 3 over 1. So, you must be very curious why some of these graphs hit each other, some don't even hit at all, or some are 100% the same thing. So now we're going to be looking at our notes at the bottom. So flip your paper over to the third sheet. So this page is asking you to reflect and observe. So part 2, use the graphs and equations from the previous page to answer the following questions. So remember, keep in mind, we want you to put these in your own words. You can phrase it how something that would make sense to you versus just writing on a piece of paper, you know, X, Y, Z, Q, R, R, you know, anything like that. So definitely look it over with us, and you can write similar ones. It's just make sure you know what you're talking about when answering these questions or looking back at them. So column A, it says list how the equations in column A are alike. So we're going to look at the equations first. So how are equations 1 and 2 alike? Well, I'm going to look up here. This one's going to be the easiest one to see. Did you notice that both of our slopes were the same and our y-intercepts were different? Same thing with down here. They had the same slope, different y-intercepts. Same slope again, different y-intercepts. Even if it's just slightly off, it is still different intercepts. So list how the equations are alike. You could say they have the same slope. How are they different? They have different y-intercepts. Okay, and what patterns did you notice after you graphed the equations? So look back and look at column A and look at the graph specifically. And yeah, they are different colors, but that's not what we're looking for. Did you notice that they're parallel to each other? Or that they never intersect? Anything like that? Yeah, I bet you did, right? They never hit the lines. No matter how close you thought they were going to hit, they never did. So, patterns that we noticed, the lines are parallel. You could say they never hit or intersect. Okay, you can just say hit each other, or a word you would see in math is intersect. Okay, so then now let's look at column B, and we're going to look at the equations, see how they're alike, see how they're different, and then we're going to look at the graphs. So take a second and pause, and I want you to try and see if you can notice in column B here what is different, the same, anything like that. Alright, now that you've paused it, you might have been able to see something that's similar. What was kind of similar about them? I noticed one difference up here for the first one, negative versus positive, but then the next one was both positive. So is there anything that's really alike or different about them? Not really. So we didn't really have anything that would be alike unless you can think of something. Things that were different. The slope and y-intercept. And what kind of patterns did we notice? So looking at the graphs up here, we noticed that there was a little bit of a pattern. One is increasing, one is decreasing. You know, we have to at least have one increasing and one decreasing in order to intercept. So we can write something like that. So what kind of patterns do we notice? One graph one graph was increasing, and the other was decreasing. Or you could say one had a negative slope, one had a positive slope. Anything like that would work. So we're going to leave the like alone for right now. Let's look at column C. What did we notice about the equations that were alike? So these ones we actually had to solve completely out. Did you notice something that they're alike? Yeah, if you look closely, they all have the same slope and y-intercept. So looking here, the intercept was 3, the intercept was 3. The slope was 2 over 3, the slope was 2 over 3. Even down here, the 4s and the -3 slopes, okay, those are all alike. So they have the same slope and y-intercepts. Okay, differences that we saw, we didn't really see any differences. Okay, and the patterns that we noticed after we graphed the equations, we can say the lines were right on top of each other. Okay, so let's move on to the words over here. So what is a solution? A solution is. So a solution for math is a value we can put in place of a variable. So example x, right? That makes the equation true. Remember how the other day we were checking and making sure that the equation had a solution and that the point of intersection was that indeed that answer? Yeah. So we are going to look at how do you know which of the systems of the equation each of them is. So no solution when looking at the equations. So dealing with no solution, guess what was the same? These slopes were the same. So when looking at the equations, how do I know it's no solution? When the slopes are the same, but the y-intercept is different. Okay, how do we know when looking at graphs? When the two lines are parallel and you could also say they never intersect. All right. So infinite solutions. How do we know when it's an infinite solution? Well, when looking at the equations, both of the answers were the same. Remember? They were both exactly the same. Remember when we solved it out and we got 3 equals 3? That would be an infinite solution. So when looking at the equation, the slope and y-intercept are the same. And looking at the graphs, they are the same line. All right. And then one solution, we said they intercept. So they have nothing in common. And they intercept at one point.